safely bring up some numbers. You don't have to write this down. Write it down, and I'll tell you what. This is just a reminder for you type of slide. The other thing that happens is that when I bring up this concept and I ask you to analyze some of the trig functions, meaning the like the sine function, will that pass vertical and horizontal line test? Okay, fail the vertical and horizontal line test, right? That fails it in a whole bunch of places. And then when I go ahead and actually do the other one, the cosine, same thing, fails a horizontal line test, and then also the tangent will fail the horizontal line test. So we really can't well, we have an ability to use inverses. You know how we're using inverses to find like angles and things like that? Okay, we can, but it has limits. One of the limits that it has is this, that in order for us to make our trig functions fit into a one-to-one, that means in order for it to pass the vertical and horizontal line test, there's something important that it must contain. It must be in the format of not the whole trig function, but only part of it. If I use only a cut-out portion of the trig function, I'm able to come up with the inverses. Actually, if you use the inverse property in your calculator, you could never go past 90 degrees. And luckily for us, that was enough. Because when we dealt with right triangles, we were able to get just pretty much do inverses in regards to that, but just of no more than 90 degrees. So one of the things that happens is that in order to successfully do an inverse of a trig function, it must be within the negative pi divided by 2 to pi divided by 2. And that's important. Now, what does that mean to us, though? That means that when I work on a unit circle, I'm going to have pretty much all the same properties, except for the fact that I won't be using all the same values. Now, this occurs here and also on another one. The not the cosine, but the tangent. Tangent is another one of those graphs that if I only took a portion of it, and luckily for me and for you, it happens also at pi divided by 2 and pi over 2 that we're going to do that. So in order to best help us in making a correct inverse trig functions, we're going to create a unit circle for inverse trig. So let's do that. Let's go into the signing part of this. Actually, this is the most useful part for me. Let me look for the unit circle. And since you have a unit circle on with you, we're going to label it something special. Because when it comes to inverse trig functions, let me make a new one. When it comes to inverse trig functions, you're going to use this unit circle. When it comes just to regular trig functions, you're still going to use your other unit circle. You're going to use them both in, that's where synergy is the best way to put it. You're going to both use them in combinations. Really, when you say synergy, that means you use both. This is on your unit circle. Label it this way. Put unit circle for inverse. And right on here somewhere, sine and tangent. Okay, go ahead and write both sine and tangent in this case, because that's exactly what we're doing. We're actually going to make a unit circle specifically for sine and tangent. Now, the lovely thing that we did is that we were able to make the inverse happen, but we restricted the angles to go from pi divided by 2. So write this down to negative pi over 2. And it was in between those values. So pretty much my unit circle that I'm going to use is only going to be quadrants 1 and 4. I'm going to go ahead and fill in the rest of the unit circle. You know, this is 0. This is pi divided by 4. I'm sorry, no, pi divided by 6. Pi divided by 6. Pi divided by 4 is next, and then pi divided by 3. It's right up there. And then in order to express it correctly, we're going to go ahead and put in the other trig functions right over here. This is going to be negative pi over 6, negative pi over 4, and negative pi over 3. And this is lovely because now I have a unit circle just dedicated to the inverse trig function of sine and tangent. Now, along with this, we are going to place the coordinates that go along with each of these points. So we all know that this is 1, 0. This is going to be the square root of 3 divided by 2. And 1/2. This is going to be the square root of 2 and the square root of 2 over 2. This is going to be 1/2 square root of 3 over 2, and we know that this is 1. So that's, we'll fill in our points for quadrant 1, and then we'll also go and safely fill in the points for quadrant 4. The points still have the same property, being that it's in quadrant 4. The only thing that changes is the y is negative now. So that is this square root of 2 over 2, negative square root of 2 over 2. We'll have 1/2 negative square root of 3 over 2. And then we'll also have 0, negative 1. So this is all nice and delightful. Now, write this down because we're also going to, as an added benefit, it makes good sense to actually write the tan functions or the tan values along with the sine values so far, because this is going to be our inverse unit circle for both sine and tangent. So let me give you a little bit of time to finish writing the sine ones, the sine values. All right, good. Okay, now let me continue the process. Now let's write the tangent values. The tangent values are going to be here at 0. I'll make them in red too. This is square root of 3 over 3. This one is 1. This is square root of 3. This is undefined. And the ones over here, this will be negative square root of 3 over 3. This one will be negative 1. This one will be negative square root of 3. And this one will be undefined here. Okay, excellent. So I have all the values I need for my inverse trig. So I'm ready. You are ready to answer any trig that has, like, if you see any trig function that has a little negative 1 next to it, they're asking for the actual inverse of that angle. Well, actually, the inverse of that value. The only time we ever use the inverse in any capacity was for the sole reason of finding the angle, which means that when you see one, then guess what you're going to give me? An angle when you look at one. So it becomes easy because now you actually have the inverse. Now we have an option. Do y'all want to deal with the sine examples or tangent? Okay. All right. So go ahead and do this. Write this down. Write them down. I need you to write down these 3 examples. Where are these over here? Not that one. Oh, right here. Okay. Don't write any of the words. Just write down these examples right here. We're going to find, and if you want, you can write this down. Find the exact value of each of these 3 trig functions. All right, now one of the things you're going to love is that having the inverse trig function makes the process of solving these very easy. In the essence of this, if I ask you to look for the value negative square root of 2 over 2 as the sign, as the y value on your inverse unit circle. Because remember, you see the inverse? This means that you need to use your inverse unit circle. What angle do you come up with? Remember, look for the y value on the inverse unit circle of negative square root of 2 over 2. Yeah, you came up with negative pi over 4. So that means that this solution is just negative pi over 4. It's pretty easy, isn't it? Now look at for the sine value of 1. What angle do you come up with? Well, actually, that's the tan. The tan value is the one in red. Yeah, well, it's actually pi over 2, right? It should be pi over 2. When you look at the value of pi over 2, okay, and you look at, because remember, we're referencing over the sine. So you got to make sure you don't get, since we have tangent and sine values on the same unit circle, you got to make sure that you don't get those tan values confused. So it's going to be pi over 2. And it's because of the sine. You're looking at the y value of the sine function. And let me bring it up so y'all can see. Let's see. Let me go back here, the pages. The only reason I didn't have it like reference over is because I had it way over here. Okay. If you look at the sine, which is the y values, does everybody see how it's right up here? So that's the reason why it's pi divided by 2. This references over to a tangent value. So had I asked you the tangent angle of 1, then y'all would have been, those people that wanted to answer that was it, then you would have been right. But since we're dealing with sine, then it was not. Let's go back and actually answer the rest of the last one. The last one, did you all get the answer for the last one? Yeah, that's pi over 3. So easy, right? You could safely get answers as long as you're looking at the right unit circle in the regards to the inverse of it. Now, we're going to get into, there's a slide that explains a concept. That means that since we're dealing with these one-to-one functions, we have the ability to say that if the value exists inside your inverse unit circle, then the inverses cancel without the use of doing a manipulation. That's really what this is all saying. That if you have a function and an inverse, if your inverse exists, if the value exists, then you could just cancel them out. This concept is not required for you to actually get a right answer. So I'm going to go ahead and show you. Some people will understand it and apply it. It's fine. Some other people, if you have to do it the long way, it's fine too. You can still get a right answer. Write down these 4 examples right here. We're going to be dealing with some inverses and some regular ones. All right, now I have 4 of these values up here. And I want to share with you a special effect that happens if, now, of these 4 values, which of these 4 are actually inside your inverse unit circle? Yeah, the top 2, right? Yes, you're absolutely right. The bottom 2 are not. Those top 2, actually, it's very easy for you to get an answer by canceling out the sign that is the inverse and the sine. But I'm going to save ourselves, or I'm going to assume that somehow you forgot that concept. Let's say that you did not remember that if it's inside your inverse unit circle, you would follow the procedure of this. You would sit here and then identify what is the value of sine at pi divided by 4. You could get that value from your regular unit circle if you want, or actually your inverse unit circle, because that value exists in there too. But what would be that value? Yeah, it'll be the square root of 2 over 2, which means that this really equals this. Now, when I ask you to then take the inverse of that value, which means reference back to an angle, go back to an angle by looking at your unit circle, wouldn't it reference back to pi over 4? Because isn't that sine value pi over 4? So what I was trying to say in a small speech before I started, that if this value exists, you could have just easily just canceled these out and be left with your pi over 4, because that value exists inside your inverse unit circle. Yeah, it's pretty much there. Like I said, not everybody's going to remember that idea. Okay? And sometimes it may be safe to actually do it the long way. Because this one, these cancel, so that's good, because it's going to be the square root of 3, because we know that this value exists in there. But look at this one is not present. So it's in this one in where we're going to go ahead and do it the long way, just like we did on top. But it's not really that long, it's just an extra step. What it really refers to is this. Okay, this value is not in your inverse unit circle, so you can't use your inverse unit circle. You must use your unit circle. Look at your unit circle and tell me, what is the sine value of 3 pi divided by 4? Yeah, square root of 2 over 2, right? And what is the inverse of square root of 2 over 2? Now you look at your inverse unit circle, pi over 4, and that's your solution. Your solution now becomes pi over 4. So this is how you go about solving these. You take it, you use your unit circle, and you use your inverse unit circle in order to get an actual answer. Now this next one, this one doesn't show up on the inverse unit circle. There's not a method. This is like an error. It doesn't exist. So this last one would be an error. It doesn't exist. We can't come up with the value. Can't take the inverse. Yes. No. It's saying that if this value is on the inside, if this value is on your unit circle, then you could just cancel. But I can't do that. Yes. Well, because when you look at your inverse unit circle for the square root of 2 over 2, it's going to be pi over 4. Okay, because you got to go back and reference back to your inverse unit circle. All right, lovely. So this is how most of them are going to run. Actually, we would have done the tangent example. We would have done things exactly the same. There's something important we have to do before we leave. On the back side, there was another unit circle. Flip over to the back. When we deal with cosine, one of the things that we're going to realize is that cosine is one of those trig functions that in order to get the one-to-one, it needs to happen between 0 to pi, which means it needs its own unit circle. So we're going to build a unit circle for cosine. Let's go ahead and you're going to label it. Go ahead and label this one. Label this one inverse unit circle or unit circle for cosine. Okay. Now, the first thing we're going to do with the way that cosine is different, it goes from 0 to pi. So fill in those two extremes, 0 to pi. That's only where the inverse exists for cosine. It's just between 0 to pi. And that means that we're going to fill in all the other angles for the unit circle. So we'll just do pi divided by 6, pi divided by 4, pi divided by 3, pi divided by 2, 2/3 pi, 3/4 pi, and 5/6 pi. So we're going to have all these angles that exist just for the inverse of cosines. We're also going to go ahead and just put in the values for these values of the unit circle, which means that we're going to do 1, 0, square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, square root of 3 over 2. Oops, that one's written wrong. The wrong method. It's 1/2 to begin with on that one. We're going to have 1/2 square root of 3 over 2. This one's going to be 0, 1. This one's going to be now negative 1/2 square root of 3 over 2. negative square root of 2 over 2, square root of 2 over 2. And this one's going to be negative square root of 3 over 2, 1/2, and with my last value being negative 1, 0. All right, lovely. What we just did is take the 3 unit circle. They're related to the original unit circle, but because of its properties and the way we, I want to say cut them, the way we restricted them, actually better put is the way we restricted them, it's better to just write out actual unit circles for the inverses, because then it's easier to understand that your values need to be here. Your values need to exist between these ranges. Otherwise, you're probably going to be getting values from everywhere in the unit circle. So that's the thing that I do love about this. All right, listen, you're probably going to be able to do questions 1 through 18. Probably only questions like 10 through, I think it's like 10, yeah, no, 7, 8, 9, and 10. Those are going to require a little bit more manipulation. So you may not want to get into that. But what we are going to do is that the assignment y'all picked up, we're going to work on that tomorrow. So maybe start on that tonight. We'll finish it up tomorrow, and then on I'll check it tomorrow, and then we'll start getting ready for today's Tuesday, right? Yeah, we'll start getting ready for the test on Friday. Yes, so 5 over 6 negative 3 over 2, correct? Yeah, negative square root of 3 over 2.